Hello.
Hello.
Oh, it's great to be back. Hello to our viewers. Hello, Adrian. How are you doing?
Hello, Dennis. How are you doing?
I'm okay. Bit low energy. Kids have been sick all week, so we're recovering.
Parents always have mid-low energy levels.
Yeah. So
Yeah.
today we're talking about QA. I mean, primarily QA, the department, the process, the mindset. In the context of TDD, how does it play along? How does the culture of developers testing and some other people, testers, other processes, having testing responsibilities, how that mixes together. We'll be looking at sort of what kind of mindset to adopt when it's a dysfunction, what the common dysfunctions are, and how to navigate that. If you have flaky tests, slow tests, who's responsible for that? How to navigate your amount of tests and where you test them and who owns the pipeline. So that's today's conversation. We're going to start off slow with the basics and go over some terminology. And then at the 1 hour mark, we'll be sort of closing up like the main content and then open it up for QA a little bit. James Gallion. James, hello. So if you have any questions, drop them in the comments. I'll be looking at them on LinkedIn. I'll be looking at them on YouTube. Yeah. Adrian, you're very proud of your using your staging environment as a sort of hot trunk-based development target, and then doing QA alongside that and deploying directly to production.
It's all about being proud, right?
Yeah.
So why do I think it's important? So first of all, I'm not an elitist person in any way, which means that I'm not thinking like there is some form of definition how you should do things, and you need to do them like a religion. I don't like that. Religion doesn't have a place in technology industry in any way. So it is for me. So I'm partly engineer and I'm partly business person, and both things are actually telling me that I need to find the best ways to approaches to get to a good outcome, to a good result, reproducible result, to improve over time, to let's say not only met the quality, but let's say being able to even higher the bar regarding quality and still meet that in the future. So this is my idea behind that. And why is a staging system in between important? Technically, the people in my teams are working on trunk. So they basically work against development branch, which is the trunk branch. So there's no one else doing anything different or else with another branch. This is only this branch. In a future project, I would even call that branch trunk instead of development, because this is something from the past actually, but it's actually trunk. So this is the nearest state. No one is able to do anything else with the other branch, which is currently main. And the difference between that is everyone is pulling against one branch, and every time someone is pushing something, build pipeline is actually running through, building everything, testing asynchronously other things as well, like end-to-end testing, those kind of tests, sometimes even contract tests, things which are in my opinion not necessary for a synchronous test. So it's okay to get the idea of that it's not working even hours later. That's still okay. Even next day it would be still okay. The reason being for that is our context. So it's okay in our context to have that, because we have enough other things in place which basically prevents us from creating bad software. The idea of the staging system is to have something in between, which is actually the pipeline in between the developers before it's getting to the production system. So right after that, at least several times a day, we basically push to production. At least once a day, but that's when we work, let's say, when we are very active on a project, so we have several projects, sometimes we don't work a day on a project, that happens, then it's simply nothing. But as soon as we work or push one time a day, to a repository, we basically bring that to production. So every code we basically produce, every change we make is able to being pushed to production. This is a state we want to have, a desirable state. And the reason for the staging system, it's not like I'm being proud, it just makes sense for me to have a technical space where we get this feedback. So where we don't want to have this feedback is directly on production. So it's unnecessary stress for us. Yeah, we want to have. It is okay that especially with with a lot of people that things fail. That's totally fine. And then we should just fix it until it's green again, and then we can push it. And sometimes it's a little bit like the front end team is, or the back end team is. Pushing something and saying, hey, this is a hypothesis that could work better, more performant. Could you please test it in the front end? Front end team is pulling, implementing, saying, hey, great, and pushing, and then let's push this in production. So it would have been basically unnecessary to make the intermediate push, which is nothing else than passing the current state from a developer to the other one to bring that in production. You can do that, and it should be still, let's say, don't break anything, but sometimes it's nice, and this is the business aspect again. Sometimes you just want to be fast and quick in the same moment. And so it's a little bit about taking both of best worlds, but we always make sure that it is actually continuously deployed, continuously delivered, and continuously integrated. And we don't have any way to do it otherwise. So as soon as, so there is no way to push a broken state into production. And this is actually something I personally prefer. And it's a good middle ground of working together as a team as well. Huh?
Mm-hmm.
I know that not everyone is actually on the same page when it comes to that.
I am looking for one of your posts this week where we got to talk about this.
Mm-hmm.
So it was primarily this: is your developer team aligned, and continuous delivery plus business. Those two, I think.
Can you send me the link in the chat?
I'm just gonna read out the most.
Okay. Or share it. Share it. We have a sharing function.
I'm not sure how well my computer can handle sharing right now, because I can see that my connection isn't very good. I don't know why, but it is what it is. I also have some video delay. I'm not sure that's a good idea without me stuttering. Anyway, it's just one comment that stood out to me, which is primarily was this conversation that followed up a few days later. So one of the comments of the people who commented on your post was this idea that I can't do TDD, my QA department controls other tests, or I can't do TDD, we only have end-to-end tests, and the QA department is running that, and it's the user acceptance testing crew, that's a mix of QA and product and business requirements that defines the tests. And
was it Vladan?
I'm not sure. No, it wasn't Vladan. I don't want to hunt the post down, because the comments are notoriously tedious to scroll on LinkedIn.
A bit.
Because I can't find it. But I remember it vaguely. So when it comes to QA, there's common misconception about what it is. So if I just zoom out a little bit and just talk about testing, there's four elements of testing. There's testing, like the activity of testing, manually thinking about it, letting it run on production, letting it run on stage, and then maybe checking logs and checking the database, checking outputs, other systems. That's all sort of falls into manual testing. If you're doing that on production, I wouldn't even mind if you put that under the category of observability or monitoring, right? So there is a type of testing that is indistinguishable from monitoring a live system. Then there's the act of defining what the tests should be. So these are usually requirements that are either functional requirements or some kind of non-functional requirement that basically sets a bar of 99% of requests should be this fast, or there should be a low error count, or there should be a high uptime, or there should be an uptime guarantee of at least this much, right? So those would be non-functional. Functional would be when I do this kind of payload comes back. When I do that, it doesn't allow me when X is the case. I see that one the least. I think that one sort of comes in a little bit closer with TDD, right? So defining, thinking about testing plans. People think that that's what's going on in QA, but it's not actually always the case. Then there's number 3, which is writing automated tests. Once you know what tests you want, you write code that performs the test automatically. Now, there's now differentiation between, does it just observe an existing system and just do something? Or does it actually orchestrate the spin-up of a fake system where you can then simulate that behavior and then assert against it? It is this last scenario that we would call various forms of end-to-end integration, acceptance, smoke, unit, developer, right? So it's this whole quasi-orchestration to some degree. Maybe it's just a package that gets run. Maybe it's a Docker container that gets spun up. Maybe it's entire staging system that gets spun up, and then you might perform some health checks, smoke tests, etc. And there's the last step, number 4, which is writing code with TDD. Right? Now that's not testing, but that is about designing the code in such a way that the behavior of the system is first and foremost what's on the public API. So the public API is not, Gregor Hoppe has this great analogy of, naming things from top to bottom or bottom up, right? So if I say a car has a wheel, right? So it's a combustion engine, crankshaft, 4-wheel driving vehicle, right? So you name a car for the parts that compose it. Or you call it a car, an automobile, right? Because it allows you to move without having a horse, right? So it can move itself without needing a horse. That's why we call it an automobile, right? It is mobile by itself. It does not need anything to pull it, right? So that is the main behavior. And that is naming that is outside in, right? So it is this last step is really focusing on the behaviors of the system, not how it is put together and what the details of how it is put together are. And when we talk about TDD, I find it really important to focus on number 2 and number 4. And the people who are complaining about QA are usually stuck in the number 2 and number 1 land, which is, how do I test this manually? And then how do I write a text diagram to how to test this manually by a machine? And that's usually the wrong way about going about QA, about the system, about quality requirements, about TDD, because you will create a monster that is not very easily tested by a robot, because the orchestration will be extremely complex. Because the system is not designed to be testable. The system is designed to be observable in production. And sometimes the system is not very much observable, and you can see the problems if they are really bad, but you don't see the fine details, right? So that's what really, for me, that's what really quality in code comes down to. Because if you design your system in such a way that you can tell the behavior and the details of the behavior on the public API, and all that crankshaft combustion engine stuff is pushed to the edges, what in clean architecture you would call the infrastructure layer, right? So that the edge would mean that it is far away from the domain layer, right? So that it is put together by some dependency injection framework, and it's a detail of the domain rather than being the other way around. And I find at least judging by your comments, because you had a very good post this week. This distinction is not very clear. Right, so there's a lot of people arguing in like your comment thread.
I
Where
just turn off my camera for a second. Go on, please.
Okay.
No,
There's a
go ahead.
lot of detail in there where people are talking past each other. One of them are describing that issue of, well, I can't test because I don't know what the requirements are, so we're sort of exploring. So nobody knows how to write a test plan for me, but I'm sure it's not me. I only know how it's implemented. I don't actually know what the behavior of the system is. Then there's the other camp, which is the behavior of the system can only be observed by trying to manually test it. So they fall into that QA process camp of trying to inspect quality into the system, but by that time it's too late because you have built an untestable system. And on the surface, this looks like it's the same conversation, but it really misses the mark because one is extremely technical, it has to do with design. The other one is extremely entrepreneurial. It has to do with using user-facing terminology rather than internal terminology.
Sorry,
James,
I had some issues today, so I needed to make sure my camera is not breaking down today.
Yeah, I see you've changed your camera setup. So the 4 points being the activity of testing, the activity of defining tests, the test writing, and doing TDD in order to make the code, design, the architecture testable. Right, so those are, let's say, the 4 important pillars of where TDD, QA, and user acceptance testing overlap. And we can even go a little bit more into a specific topic, like BDD, for example. BDD is a different combination of the overlaps, where you might have somebody just write down expected behavior in technical documentation, and then sort of make that automatable and then infer design from that. But there's no magic here. I see it was on my comment thread this week where I keep getting this feedback that there's magic coming from TDD, that it somehow designs things for you and architects things for you. No, that's a complex problem that it still takes a human brain to do that. Like there's no, you can't cheat in software. Like you can't skip good design. You can ask ChatGPT to regurgitate a solution that is a solved problem in the public domain, so it knows a solution. Right? So, for example, binary search is a well-designed solution to a problem. ChatGPT happens to know many implementations of well-designed binary search, and if you ask it for one and define which one you want, it'll give it to you. Because it is a solved problem in the public domain. So the source is known, the source is available. It's a source available problem, it's a source available solution. What it might struggle with is explaining to you exactly how it came up to what the 40 years of evolution were to actually design that algorithm. And that's just an algorithm. That's very much low-level mathematical.
Maybe we should bring the topic a little bit more into plain English. And try to explain once more what is actually the idea of this show. So it's about TDD, it's about QA. So those are the 2 things. I remember still when we made the briefing, and the idea was how to actually get some form of acceptance for testing practices. So how do we get the world from the TDD world, which is mainly driven by the developers and engineers, and the, let's say, traditional QA testing, which is oftentimes driven not by the team, which is
management and regression targeted, less so.
Exactly, and what is the idea behind that? So how can we get those people together? Because let's say the traditional world is mostly about, we hand off the responsibility of testing it to someone else. So we have made or approached a test-driven development approach, but this approach is not, let's say, not there. There is no one viewing those tests in the QA department. They have their own ways of testing it, acceptance tests, what kind of tests ever, the end-to-end testing, visual testing, manual testing, those kind of things. And I think there's this topic today is about the bridge in between those both worlds, because there is oftentimes people test then something in the QA part, which is oftentimes the client. So in many cases, it is not even the same company doing that. Then providing feedback in form of a PDF file with marks in it, comments in Figma, comments in Miro, those kind of things, right? And you get
email thread with screenshots.
exactly, and those are actually those use cases described there often are not even represented in the test cases you have defined. So there are no stories you can test about that, and it's even that they actually have other expectations. And I think one viable solution here is to really bridge the gap. It's the very same when I'm speaking about bridge the gap between business and development, because this is actually it. The QA department is test gate for business in this case. So how do you get them closer? And this is an interesting topic today. So for the audience who is listening today, if you have anything regarding that topic, let us know. James already had two things in response. We can go through it. But the topic for today is how can we close the gap? This is the interesting part for me as well, because I think it's there are ways to do that, but it's actually hard. To be honest, that's a hard topic. That's not like, hey, we have a solution here, just practice. No, it's hard because it's about interests. You know?
It's interesting to look at the extremes first, and I just want to honor James. James said you can have TDD emerge your architecture, and anyone else who looks at your code regret he did it that way. TDD is not fast food. It's not a fast food. It's not a burger flipping fast food brainless coding. Completely agree. So that's on the comment that that there is no magical emergent property from TDD. And now we close that topic, and now we talk about how to bridge the gap between the two departments, right? If there are two departments. And James, I do see that you have a follow-up question on that. We can address that actually as we're discussing this. So if you're familiar with the shift left movement, the whole shift left movement is a sort of pragmatic approach that stemmed from lean principles of not even software, but software primarily. It's got popularized in software, where there are departments and silos, and usually design and requirements and engineering are like left, right? So at the beginning of the timeline, right, I will do it for our viewers. So left here, and then the quality, the deployment, and the user getting access to the feature, it's on the right, late in the process. So the whole shift left movement is this effort of getting areas of the pipeline which can give you negative feedback of it doesn't work, it sucks, it works but it sucks, it works but it works and it's what we asked for but we changed our mind, please change it. And what's changed? I don't know what's different. Do you see what I see? Do I have the right version? Right? So it's this confusion aspect, or it might just be bugged, or oops, I made a mess. So these feedbacks generally happen late because it has to do with the customer. It has to do with a particular context, a particular environment, and you usually have assigned people to work with that stage. The very much, the far right department is customer service. They are the furthest right? So they are the first to get feedback, and they are the least capable to act on the feedback. First of all, they are the least technical of all the available people. Or, well, I think the furthest right would be writing to the CEO who is non-technical on their Twitter. Like that would be like the most the furthest away possible from the source of the problem. Right in this metaphor is far away from the problem, because the source, the implementation of the behavior, is on the left side, is on this side. That's the engineers, that's the designers, that's the UX, business requirements gathering, even defining what the stories are, right side. what size the stories are, the release plan, if you're an extreme programming enthusiast. So how can we bridge the gap? Well, the shift left movement says that all the important, so first of all, the shift left movement says there are activities that create quality, there are activities that define quality, and there are activities that inspect quality. And the shift left movement says that the biggest focus should be on getting the feedback mechanism and the creation process as close together as possible. So you don't create it in January and then you inspect it for quality in March and then you deploy it in April. That would be like a dysfunction, right? Because
A Git flow.
the developers, because the developers who have created it very early on, then don't get any feedback. They start working on something else, and then it might fail. It has to go back into development. That's typical waterfall. That's essentially what you would expect not to be doing in good faith, in good conscience, if you've ever seen that waterfall
This is
diagram.
appfall development. So
It's
appfall.
Exactly.
In German, is actually a quite funny word. It's actually, appfall is garbage.
So,
yeah, but
I didn't get it. Okay, I got it now. So that's one way. Now the other way is to say it's more this DevOps mentality of you build it, you maintain it, you release it, and you QA it, right? So it's this more product leadership mentality. You might the Silicon Valley Business Group works like this, so that's the Marty Kagan camp, product leadership, Uber Alles. That's the sort of engineering skill and product understanding in every engineer, in one brain, and as many brains like that as possible, right? So the engineer who builds the thing should be able to test the thing, should be able to reason about the thing from the perspective of the user. This is the whole domain-driven design, event storming, event modeling, right? So it puts a lot of responsibility on the engineer to not build anything they don't understand, right? So it's this anti-code monkey discipline where you're not allowed, where you're essentially being treated as unprofessional if you have coded something that you don't know how the user is using it and why it's valuable and why somebody's paying for this.
Mhm.
We see a lot of this sort of code monkey mentality in agencies and offshoring and farshoring and outstaffing agencies and businesses where people get told what to build and they don't really care why they're building it. So that's, again, right? Engineering here, definition somewhere else, and then there's inspection. And usually inspection tied to, well, if it's good enough, we will pay you. And if it's not good enough, then God knows what happens, right? So that there's some kind of backflow, back pressure happening into the development process.
Mhm.
So how can we get this closer? So the shift left movement says, do the inspection as close as possible to the creation phase. This is essentially, the extreme of this is continuous delivery. So don't keep developing and then throw it over the wall and then somebody else will test it at some later time and then let you know about failures at an even later time, right? So the idea is, I don't start working on something new unless I have tested what I'm working on and I have a high degree of guarantee that it's getting deployed and that the consequence of deployment is also positive, right? So it is this whole idea of smaller batches and no limited work in progress, right? You can also focus on this just by limiting work in progress, where you can say this entire team is building this one feature and we won't start building the next one until we have feedback that this thing actually works.
Mhm.
Now, a lot of people are skeptical of this one because a lot of businesses, especially in e-commerce and similar, they are exposed to leading feedback cycles, right? So maybe I order something on Amazon. It might take, a week or 2 weeks for me to actually get my shipment, which means that like one positive user journey has a realistic delay of 2 weeks, 3 weeks on getting like full-scale feedback. And that's just for acquisition, and then you imagine that there's like some kind of a retention loop where you email them for cart abandonment and they come back, and then there's a reason for why the cart is now different, or maybe they got a discount. So if you're doing that without any kind of simulation and tests, it's very difficult. So a lot of people are automatically skeptical about that one and just say it's not testable. That has to do with time and waiting. That is not testable.
I would
QA start taking over, like that kind of thing.
There is a lot going on regarding context as well here. So we can't just say, yeah, monotasking is something we actually can do or not. So it's heavily depending on how you work. So there are teams who are actually no teams. They are just, let's say, a group of individual developers who take tickets, the ticket machine thing. We had that as a process.
The co-located programmers.
Exactly, and there is some key account managers, some product owners, someone or several people, another group who is constantly ordering via tickets small or larger changes. And no one there thinks of, hey, it's a good idea to do monotasking. It's about you do this, you do this, you do this, and please hurry up because there are 5 more tickets to do today. And this is I think the let's say most stupid way of actually doing software development. And for me, this is not really software development because you don't develop a software, you just work down tickets. Those are 2 different things. So there is no long-term goal behind that. The engineers don't know. In my opinion, they aren't engineers. They are just programmers. They just program to fulfill a ticket. This is all they do. They don't know what happens with that ticket. They don't know why. They wouldn't even really know how to specify a test for it because they don't know yet what it actually will be, because they start to do something, they already get the pressure.
I see the argument so often. You can't TDD because I don't know yet.
No. This is not what I mean. This is now something really business related. So if you have, and that's very often in that area, this in an extreme form of that area, which is actually quite common, you have that there is a person sending you a ticket, and while you're doing the ticket, they're sending you corrections for that ticket. So it doesn't make sense in that moment because this is such a dysfunction already in the entire process, which is not even a process. It is some very strange thing. So this is so dysfunctional that let's say changing those tests and creating those tests is simply not the thing you should aim for in the beginning. You should aim for maybe leaving the company as a programmer or try to change it. Those are 2 things you can do. I don't, in such an environment, and I say that because I know that especially on LinkedIn, many people I know are in such an environment right now. Yep. And they say then, and that's okay for me, and I accept that TDD doesn't make sense there because this process is so broken that that it's unnecessary. Where it is necessary is where you actually have software developers who are at point 0 right now, right? And in 1 week or 2 weeks or 1 year, they are on some different level. They develop from 2 and beyond that. So no one knows exactly how, why, the agile way. Their TDD and testing in any form does make a lot of sense in this case because there is no...
You meant contextualizing. What context did you want to add to the conversation, or rather to my comment when I said that there's this gap, let's say, between inspection and creation, and you wanted to add context to that? Yeah.
So that type of company, let's call it the ticket machine agency context. It is most likely to impossible to bridge that gap and get the people together. So the people who,
I agree.
Yeah, and the people who the developers don't even know exactly who those people are and why and what the idea was behind the ticket or will be after this ticket is done. So you don't know if there's coming something or never. You don't even know if it was a test or something important. So you simply don't know. And the other context is the development context, where you actually, as a team, develop on a shared goal, a vision, and you share the same goal and vision like the business. And still, and there are those who understood that and got together. I know several companies actually working quite well there.
I've worked in a few of those as well. Yeah, it's quite liberating.
Exactly, but there are many who actually have shared goals, but they are not working together. And there's just this idea of still, hey, we are different departments. Sometimes, hey, this is the IT guys, they're doing this and that. And this is where we need to bridge. So this is the actual spot where there is a lot of potential to change something. A lot of people in the audience today may be in such an environment even. There is a lot of potential to change. And this is what I mean by contextualizing. So it is a different thing in a ticket machine environment to try to change something like that, or an environment where everyone is on the same mission. This is a totally different thing to actually realize in the beginning.
Let's read James's comment then. So he said, he's quoting Edgar Dijkstra, program testing can be used to show the presence of bugs, but never to show their absence. It's quite an old quote. When something bad makes it to the remote trunk, passing through via the above code and everything is green, what safeguard prevents it from going to production? What safety besides CI/CD do you have for stakeholders to okay features before production? Production being what end users have access to. Business changing feature flag is the business releasing to, and it's cut off to end users, he says. It's just missing that one word at the end. So, if I understood the question correctly, is this ability of, if I have to know about it in order for me to inspect it, right? Because I have to write it down. I have to make an assumption, right? So it is following this sort of scientific method. It's very hard to test if a human has never thought about thinking about this problem, executing this way before, right? So if I say I have to see the dysfunction to write it down to then say, let's write a test for it. And there are some cases that are difficult to cover before going into production. And that's how I understood the question. And my answer to that, to James, short answer, because I want to hear your opinion on this as well, Adrian. The short answer is that you're not supposed to eliminate all bugs. Right? So you're not supposed to know about all bugs before you release for the first time.
It's impossible anyway.
It's impossible, right? But that's not to say that you should be releasing to production in order to do some weird form of exploratory bug hunting. That is also a dysfunction. Now, if you've never done very heavy TDD and product development in a product team where it's not a feature factory, where it's not an agency ticket machine like Adrian mentioned, but it's a team working on the same product, it might be actually very difficult to pinpoint what the middle ground is. So from most of the audiences that never mind, I'm waffling. I said short answer. Adrian, what do you think?
I had that in the last days we were working on something for a context in between those both roles. And there was a very complex app for where you have specific templates you would show and under specific circumstances, and those can be very complex to understand even for the people working longer with the system. It's a very complex domain.
Can you give us an industry?
Insurance.
Okay. Of course.
And in this case it was a little bit like there were tests already in place, but the tests were not really testing what the QA in that area was expecting, right? So first mistake, the QA were never going to 100% explain what the acceptance criteria is. So there was always like, this was always like per context but not domain wide. So the contexts are very aligned together but not domain wide. So you would work in one, and this was done for half a year. And there was a summation of different, let's say, feature sets which are actually doing the same thing but could have been differently. And those were all covered, and they were all working. So for each of those were at least the end-to-end tests, testing even
locally.
Yeah, locally, exactly. But the problem was there were overlap in between those contexts, and no one was seeing those. And this was what the point then, and how we solved it actually is to really say, okay, business, tech. So just in a simple way now, we're getting together. What shall be there? We took a look at pictures, right? This should be there, this should look like this. And from that on, we abstracted some form of specification under which circumstance, which output would be expected. And then we basically put that into a test plan, we put that into a specification, we updated the end-to-end tests, and then we started to implement it, and voila, first try it was working. And that was how we bridge the gap between business and development. And this is actually this is still uncommon, because somehow it always tends to get, again, let's say, gapped again.
That's a very human gap. The gap has to do with me, an engineer, let's say, walking up to a business expert and saying, explain every scenario to me, please. I don't understand anything. Please explain every scenario. And of course they get annoyed because there's so many scenarios. So then you sort of need help understanding, okay, how do you decompose? Right? So the permutations are astronomical. I can't produce a document that has all the permutations. So you need to, me the domain expert now is telling you, the engineer, well, you need to understand this and this and this about the system. There are elements here which are a little bit fuzzy on the edges, and the complexity is in the number of links that we can do, not in how many components we have. So what we really need to understand is what is the cohesion of the links. There's this kind of process, and it has like these 7 workflows, but they all follow the same rules. And then there's these 3 components that follow a different workflow, but the rules are completely different from the first group, right? But there are groups, but the groups have no components. The groups just follow regulation. They might follow a very particular type of like subsystem, subcategory of user, subcategory of insurance policy type, or something like that, right? Or date, or country, or one of the key components of maybe it's a car, maybe it's not a car, maybe it's something medical, and then it follows different rules. So the rules have to do with links between things, not the components. Same thing with architecture. Architecture is complex because it's about the configuration. It's about what are the links between the pieces. See, a lot of people think, okay, if I have a atomic piece, one Lego brick, then all I need to do is just test how many different ways I can use this Lego brick. And that's silly, because you might put it together in unexpected ways, and then you putting a Lego brick onto another Lego brick, onto another Lego brick, onto another Lego brick, onto another Lego brick. If you put 100 on them, the first one might break because of gravity. And that is a test you've never done before, because the atomic piece was never linked with this kind of configuration. Because when the configuration is complex enough, the complexity of the links actually has behavior. And that's the important part that I pretend that we want to capture in QA. But to me, QA as a department, if I can now connect the dots with you, Adrian, regarding, you mentioned QA in that context and the agency, and differentiating from coders and responsible engineers who are working together as a team. I think if you forgo this silo mentality, the QA department, if there is a department, the QA specialists, what they should be doing is teaching, coaching the engineers, the product people, the managers, how to think in QA terms, how to perform QA, what is reasonable to inspect, what is necessary by law to inspect, how can we inspect it, what is a reasonable way of inspection, how can do we inspect or do we prevent? Where, in which areas do we do prevention, right? So, for example, GDPR in the EU, we are heavily in the prevention area. Like, we should prevent oversharing private data, rather than oversharing and then trying to make sense of it, keeping logs and deleting it, delete. Like, you just prevent sharing it in the first place, like keeping it in a vault, etc., etc.
Yeah, least principle.
Right. So it's mostly, if you have like a competent QA department, they shouldn't be running tests. God forbid, early on in my career, I was in like dysfunctional setups where the responsibility of QA was to write Cypress simulations and then run them manually. Run them in their local machine and then look at what breaks, and if something breaks, create Jira tickets for it. Right? So it was this automation in a human, that it was backwards. It was way too slow, frequency was way too low, the latency on the feedback was way too high, and the human could make errors in judgment, errors in execution, report things that are not fixed, report things as important that were benign. That's the worst, where the QA person, blocks my deploy because you think something is terribly wrong with it, and I look at it and go, no, that's actually a very rare use case, and a normal user can never reproduce that. Here's the proof. And they say, no, this can't go to production. And I hate discussions like that. And I had a lot of discussions like that, early on in my career, when I didn't know where the boundaries were. I didn't know what exactly the responsibility overlap was. It's like, when you're doing QA and you're telling me this is not correct behavior, are you designing the system? Are you doing engineering? Because that's what it really is, right? We're engineering. We're developing software. All of these processes, the output should be developing software. So the n+1 iteration is slightly better than the n iteration. Now, regression testing, if you notice, doesn't guarantee that. It only guarantees that if I keep increasing the sweet size of regression tests, then at least I can maintain the same level of quality. But it never improves it. A lot of people miss this detail. You cannot inspect quality into the system. Regression tests only check down, is it worse? But it will never make it better. And to a lot of people, they think that is the maximum that we are capable of for quality. But it's actually a very low standard to just have regression tests. And that's what James has been talking about, right? So just testing what you can predict is a very low bar for quality, because that alone will never increase quality, right? So what will increase quality is actually, ironically, prevention, not inspection. It's to prevent all the bad behavior. It's like, oh, well, I have a very unstable component here. Well, I'll just not let you use it. I'll feature flag it. I'll make sure it's extremely defensive about its behaviors. I'll make sure it throws errors very early. I'll make sure the user sees the error and can respond to it and can complain to customer support if necessary.
Yeah, that's one of the biggest things I face so far as well when it comes to testing, where people really try to just test the current state. But let's say if you have just, especially in smaller apps, this is oftentimes something, let's say, invaluable. Sorry, no, not invaluable. It's basically there's no value in it because people are you can see it anyway. So the chance that you break something with a very small team on a very small app is quite low because you can oversee most of the stuff anyway. It is more complicated in large apps where you do a lot of refactoring, where many people working on that. There you need to have it. And as you said, or let's say connect that back to my example I had with the insurance stuff. As soon as you understand what is allowed and what is not allowed in that case by persons who understand the business side of it, and you as an engineer make notes and then you ask, hey, but what is in this case? Because as an engineer you oftentimes see technical cases the business people don't see because they only say, but this and that can happen in the same moment or can't happen or is not allowed to in the same moment. But you say, yes, but if we implement it like this with the API, it will be like this.
Yeah, business people generally tend to pragmatically, optimistically filter out unreasonable cases.
And exactly the same, or let's say the vice versa thing, the opposite is what the engineers are doing. They need to find
they try to find all permutations, but it is also harmful to the business to hard code all permutations. Right? Because we had a comment from Stefan Schmidt. He was with us last week. Great episode. One of my favorite episodes lately.
I need to still upload it.
But it was one of my favorite episodes. I really enjoyed that conversation, like where we went, how the conversation went. Really enjoyed that. And he says he likes TDD end-to-end versus unit TDD, right? So it's this idea of inside-out, sort of more smaller atomic piece TDD testing, or sort of more configuration TDD testing, like testing the behavior, pushing the infrastructure
I like both,
to the edges.
to be honest.
I also like both. It usually gets misconstrued as this sort of Chicago versus London kind of thinking, but I like to more focus on this ATDD style of testing, where I allow myself to use Cypress, end-to-end testing tools to get access to a high level of orchestration, but then not abuse it and actually target behavior. I might just mount a component. I see this very often in front end. You do this as well. Nick Shoemaker taught us how to do this as well, where you might use a very broad end-to-end testing tool, and then you use this powerful tool to really limit your scope and say, you know what, I just want to mount this component in an isolated environment, but I want the isolated environment to be a fully fledged browser. And then you run tests within that container. And then,
but this is not a unit test. This is what we call component tests. So this is a new form of testing which came with the new front-end technologies.
It's an integration test that targets a specific behavior, opposed to integration testing that's testing integration, right? So we're not testing the infrastructure. We actually care about behavior that is only reasonably emerging in an integrated environment.
I actually have an example about that. I've talked to a colleague today because I wanted to explain that. Let me take a look. Maybe I can share this quick.
Sure. Can I read Raul's comment real quick?
Yeah, just go ahead. I will prepare.
All right. Raul mentioned, how about for companies that use scheduled version releases? They gather several features, fixes, etc. till that date, and this scenario could harmonize everything as you guys suggest. So, again, not knowing anything about the context, Raul, of this kind of company, think about it in business terms, right? So if you have a scheduled release, let's say there are now two extremes. Let's say there are scheduled version releases, and there are two versions scheduled every day. So every 12 hours, a new version goes out. Harmonizing is extremely possible. So Stripe is an example of this. Okay, what I just said, Stripe does that. They just have scheduled releases, and they release 100 times per day, and then two of them are have major version numbers, and then those two make it to your iPhone, if they're doing mobile app deployments for the iPhone, right? Because they actually can't create as many final release deployment artifacts as they do deployments, right? So they are in this high frequency deployment strategy where the number of releases they can do is much smaller than the amount of deployments they can do. Same with Chrome, right? So they can push the trunk faster than distributing a rollout of a new version. Now that's one extreme. For that, harmonization is very simple. Now there's the other extreme. Now flip this scenario around. There's one release scheduled every 3 months, and people are pushing the trunk daily. Now this is a completely different scenario, because the release time, or if I call it the lead time for a release, is much bigger than the shift of a single employee. If a shift of a single employee is, let's say, 8 hours or 6.5 hours, right? So that would be a work day minus lunch minus one meeting. Then the lead time for the release is 3 months, and a worker's shift is 8 hours. Well, the scale discrepancy of that will cause people to push things to the extreme, which is closer to the release. Which means the most untested feature is the one that I finished day one. Because that feature needs 3 months of delay to get feedback back to that person. the feature you do one day before the delay, that one might actually be of high quality, because if you finish it just the night before the release, you immediately get feedback. And a lot of people get addicted to that. A lot of people then get into this dysfunction of, there's a 3-month deadline, we will release on the deadline, and until the last day, I'm still coding critical functionality. And they might get addicted to then putting the critical functionality on the end of the project, because that's when they get feedback. And they do that completely subconsciously. And it is one of the most unintuitive wastes and unintended wastes that I see a lot of just uninformed or misinformed software companies do. Because ideally what you want is, right? Because then if I tell them, no, release every week, and they will say, oh, we can deploy, but we won't release. Because if the feedback happens on release, not on deploy, then if I make you deploy more frequently, then you might actually get to the important feature sooner. But because we haven't dealt with the feedback cycle, I have now moved you further away from your feedback, from your feedback delay, right? Because otherwise you might have been working on something else more benign. So that it's very important when you're shifting left, everything needs to shift left. You can't just shift inspection, or you can't just shift development left. A lot of people start way too early in shifting development left of, oh, the engineers should be coding much more closer to the UX designers. No, never mind that. It's the deployment aspect and, talking to customers through customer support. That should be happening closer to engineering. It's that thing that needs to be shifted left, not the already very far left things, because that's the easy stuff.
I would like to add what came to my mind when I read first the comment was with shadow releases. So in more modern web development things where you don't really have something you need to upload in order to have a new version. So let's say no app store or something like that, or even app stores with modern web views. So you have something where you run in continuous delivery and you deliver changes every day. But I had that confusion several times when people ask me, hey, you said you made some updates, but I don't see them. Yes, we made some updates and you don't see them. And the point is, it is about those were continuously, delivered in a shadow form to the system. So we were basically, let's say, behind a feature flag, only to a specific user group. So let's say conditional appearance rollout, right? So maybe only just a few people to test it, get some feedback how it behaves, performance testing, those kind of things. And you can gather them as well, where you say, okay, we have now 5 features behind a feature flag, and as soon as we turn on this feature flag, which can be some kind of how's it called, launch darkly, for example, those kind of tools, or just change a flag in environment variables from 0 to 1, and suddenly after 2 minutes everyone is seeing those changes. It's a simple version of that, and this is a release as well, so you can test it, and even if you see, oh, there is something going wrong, then you basically switch it back, and you know that it's actually working because you had already the feedback that it's stable in production. At least let's say you can stable in a stable way switch forth and back. And this is what you want to have in order to get the confidence to roll out. What you don't want to have is, what you don't want to have is something where you can't roll back because you have prepared something, then you ship it and you realize, oh, that doesn't work. We need to hotfix and patch it right now. So this is where we got to the patches out there, right? Yeah. And it is way cooler if you can just for example, go to launch darkly, turn off the feature, take a look into your monitoring, and if you have good observability, that should be no problem. And then you see, are there is there user misery, are there error logs, something like that. And then you can even make a major release without the people knowing that they actually have downloaded anything new. And this is what I personally like most.
Yeah. I work with a lot of, and we can be even more concrete now, because we need to define what quality is, right? Quality is not just about, does it work? That's a very low standard. Last year I worked with a lot of startups, so smaller businesses that are a little bit more chaotic, and but they've grown enough to have, let's say, multi-track products. There are multiple products within the organization, then there are multiple teams overlapping on the product vision. And their biggest concern wasn't that features weren't working. Their biggest concern was that they rolled out a feature and then they didn't know whether the users were using it. Right? So there were so many micro features in the system that they didn't know which ones were useful. They didn't know which ones were being used most frequently because they were looking at the system as a whole. Right? So a lot of people ask me, first time sort of continuous delivery adopters, directors of engineering, VPs of engineering, usually, startup CTOs. I have to sort of highlight that, right? So it is, as Stefan mentioned, the person who cannot bubble up responsibility anymore, right? They usually get surprised when I tell them, no, like, it's enough that you know that it can be merged safely. That's already valuable, right? Because then we don't need to stay on the branch. A branch invites technical debt because somebody will need to do some kind of octopus merge or some heroic on the weekend to undo it, to merge it, to resolve some conflict. God forbid to get lost in some like weird interactive rebase and then lose 2 hours for nothing.
Rebase is one of those functions.
No.
I wish you could turn it off and only turn it on if you have admin rights or something like that. Oh, I found this button rebase. It was blue in my ID. I clicked it. Why? I'm rebasing since 2 days and everyone else is complaining. Don't know why. Right?
Then if it takes too long,
where are my changes?
And you can get stuck in that. If the rebase conflict resolution takes too long, there might be 2 new commits by the time you're done. Then you need to do it again.
There is no point of rebasing. Yeah.
A lot of teams get stuck in that. No, but my point is, one of the highest levels of quality that you can give to the engineering team is that when they roll out a feature, they immediately get metrics on whether it's being used, why it's being used, and if they're not getting quantitative data, at least to get some survey feedback or some kind of qualitative data from the people, from customer support, from product, from people who do interviews with B2B SaaS, for example. You don't really have customer support. You have business partners, right? So you need to talk to your business partners and interview them. Okay, is everything okay? It was like, was there a huge issue or any incidents? And then most of the feedback is qualitative, not quantitative. You want that to be as soon as possible to the development effort. And that has to be a process. That has to be a codified process, which means, okay, for which tenant are we building this? Okay, and how soon are we expecting feedback? What can we predict to test? What is worth testing? What major behaviors do we guarantee? Okay, that needs to be test covered. And then if the major behaviors are green by the automated pipeline, the pipeline will deploy itself. Right? So the point with the rollout, where I'm proving that it merges correctly and deploys correctly, is dependent on a automation that we have written that at least checks whether our guarantees are met. Right? So if I say I have a closed website, for example, Circle SO. In order for me to use Circle SO, login and registration need to work. But more important than registration, login needs to work. Because if I can't create a new community, that's fine. Nobody's expecting that community to exist in any way. But if I can't log in to an existing community that already exists, that might have a meeting today, that's a huge problem. So one of the guarantees would be that at the very least, you can log in always at a high guarantee of uptime, and you can always go to at least this and that page, right? So at the very least, at the very least, you can go to the GDPR forget me request. At the very least, you can get to the close my account and forgot password path, and at the very least, you can get like the basic emergency notifications from the community itself. That might be a guarantee, and that guarantee can be automatically test covered. Now, how you manage to automatically test cover that? That's between you, the product people, the QA people, coaching each other and helping each other understand the problem better, to decompose it in a way that then is easy to test cover broadly with few test cases. What you don't want to do is then to have a million tests to just, really pinpoint like a key behavior. You are sharing something, and then James has another follow-up question. Let's go with yours first.
Yeah, I'm not sure if this is even fitting the context right now. So
we're talking about behavioral integration component tests.
Yeah.
It is contextual because we just finished on this topic.
I just wanted to quickly share something because that I had that as well. And the idea was it's a little bit the difference between what you want to test actually in a test. This was about that, so it is not 100% effect. But what we have here is actually a form of content management system, and this is a Cypress test for this component. And what this test doesn't do anything right now, and people were basically discussing what we shall do here. And the point is, here are actually 2 or 3 components involved. And we have one component here, one component here, and one component here. The first one is a slate editor. The second one is a slate editor. It's basically the same editor with different configuration. This is just for the title, and this is for text, so you can do anything there. And there's a third one, which is a button, where you can create a button, and there are different let's say different states depending on what. So you can basically add a label, and then you can add some thing here, save that, and then it's actually a button. So, and the discussion was, or the attempt was, and that was what I actually prevented, to have that tested here inside this component test. So what the idea was to test the title and the entire functionality of the title. Test this one and the entire functionality of that one. Test this one and the entire functionality of that one in one big component test. And this is what I personally dislike, because those components themselves need tests. So actually there should be one test for those. Yep. And there should be one test for this. And in in this test, or the test for where we are actually right now, which is unfinished, should only test the combination, the aggregation of everything. Yes. So is it actually working together? Is it maybe saving some state to somewhere else?
Is one of them hiding or overlapping over one of them? And then
exactly. Are they all 3 available? Are they all 3 available? And can you do the very obvious things? This is what you want to test here, because you don't want to retest every time very same things. And then just, refactor it 10 times in a row. And I think this is very important to understand. So this is a integration test for actually 3 components, which should have, let's say, more. It's not a unit test, but it's going into the direction of a unit test. So you only test this unit, and unit, and make sure that those in integration work together. And you actually bubble that up. So if you have that in a real end-to-end test scenario, where everything is, so this is still a mock, but if you don't have that in a mocked version, so in a real version, you would actually test with the end-to-end test, for me then, just if a press on the button plus press on save to server, something like that, is actually saving to server or not. So this is then for me the end-to-end test, which is actually the user is doing. But the end-to-end test should not test this, what we've mentioned before, anymore again, right? So I hope that was a little bit understandable. So of course you need context from the software.
Raul has a follow-up question, which is a very good question. Raul asks, is that like a UI smoke test?
This is a smoke test. This is a smoke test.
Yeah.
That would be so saying this is there or not, this is there or not, this is there or not, is a smoke test actually. So if one is not there, so they are not there, but they don't really tell you why. That's still good to know.
Yeah? What makes this an integration test is that in order for us to create this neighborhood, essentially, we are integrating the 3 buttons on a piece of infrastructure that is integrated into the real infrastructure. So in this case, we have some HTML, some JSX that has nothing to do with the components, and that is part of our test scenario. And that is what we're integrating into, and how they are ordered impacts the outcome of the test. That's what makes it an integration test. We're integrating with an external, imagine integration means that there's a foreign object involved in testing, right? So a developer test would be closer to what you would normally call a unit test, although I don't like this term because it's very hard to define what a unit is. Because it should be a unit of behavior, that's why it's a unit test. But A lot of people don't use unit
Sometimes
tests.
it's a function, sometimes
function,
it's an
but a
entire
function.
component. Yeah.
Yes, but a function is not a unit of behavior. A unit of behavior is a well-abstracted business concern. And a lot of people aren't very good at abstractions. They just compose things, right? So if I have this is not abstraction. This is composition. So I haven't explained what this composition means. The abstraction of this composition might be create new post. Create new post has a title, content, and save button. So what the user is doing, that is one unit of behavior, create new post, and it needs 3 components. And I am testing the outside abstraction of that. That's the behavior. But usually when I say unit test, people don't think about it that way, right? Because it should be one interface being abstracted and tested against with isolated controlled test doubles, fakes, mocks, etc. This is an integration test because we are not controlling the neighborhood, right? So there is a foreign object to the test, and that foreign object is not controlled within the test suite. It is supplied like a little infrastructure requirement, like a database would.
A little example here, for example, if you would test those alone, like this text field, so you click into this text field.
It's like the Lego example I made earlier, right? So you only see the Lego breaking when you stack so many of it that the weight actually crushes the bottom.
This is what I mean right now. So you have that here, you test it all good, right? And you would test that one alone, and oh, sorry.
Yeah, you made it reload.
So you test that this, and you have this. For example, you have this mode out, this the slide out, which is coming out, and you close the slide out again. If you just test this button with the slide out, it will always work, or there's a high chance. But this doesn't mean that together those work as well. So maybe here's a z-index mismatch or something like that. You open that, and the other component is above that, and you can't click here and type. And this is actually a dysfunction you only see in that kind of test. And this is the reason why a mix of tests is actually valuable, right? And you need to make sure that when you think about those things, what can go wrong, maybe to think about that as well. So it is always important to test the unit, but as soon as we get into front end, and front end is a little different than back end actually. Front end does have a lot of layers. You have the HTML, you have the CSS, you have the JavaScript, you have state, you have re-rendering, you have browser concerns, you have browser rendering engines, you have are you actually in a browser? Are you in a web view? Are you in a controlled environment? Are you in a maybe even in a email browser?
What is the top level domain? Is it localhost? Can you have an HTTPS certificate?
There's so much going.
Certificate spoofed.
And this is why Cypress is becoming more successful, because it is way closer to the actual environment to test.
Because it is abstracting a large part of the foreign elements that are irrelevant to your business case.
Now, let's get back to it.
Okay. I just wanted to make one more comment on that, like that component and unit testing distinction is that we don't want a permutation of all possible test cases, even on the back end. I see a lot of people do this, where they create tests and they do crazy stuff like, what does it behave like if I add 0, or if I forget one argument, or if I add infinity, or if I add -1 and it's expecting an integer, or if I say string this, or empty string with a space. They're testing the edge conditions that a normal user wouldn't care about, and those are just non-functional requirement. Like, how does it fail? When it fails, does it expose critical behavior? Like, what you're actually testing there against are corner cases of security, essentially. Does it crash in an unsecure way? Can it be hacked? But that's not testing behavior. Behavior means that you are capable of expressing a high-level abstraction without using the terminology of how the components are composed together, right? So, and I'm not talking about inheritance when I say abstraction, right? So, calling an automobile because it drives itself and doesn't require a horse, that is an abstraction. calling a automobile a combustion engine crankshaft with pedal with 4 wheels with a roof on top and a little windshield in front that requires a pilot on the left side, that is talking about all that configuration, all the possible components, right? So if I'm talking about the automobile as in when I hit gas pedal, it moves forward. When I shift that way, it moves backward. I'm talking about the movement of the automobile. When you're talking about the constituent components, you might say, oh, when I do this, the crankshaft turns that way, and then when I do that, and when I put the system into that configuration, the crankshaft turns that way, and it's clockwise or counterclockwise. Clockwise means it's going forward, counterclockwise means it's going backwards, right? But you lose the context of what is moving backwards. Well, the automobile. Well, what's the automobile in the test case? Well, there isn't one, because I'm just talking about the components. And then this behavior thing just becomes an afterthought. Then the engineer needs to know that crankshaft testing, oh, that's the thing that the user cares about. But they don't, because they don't use this language, right? So there's this translation necessary. That's what we're trying to uncover with, QA processes, with shift left mentality, with domain-driven design, event modeling. I have a very good anecdote, by the way. You mentioned earlier, Adrian, that TDD is not possible when you have, let's say, irresponsible management or irresponsible development practices, where it's just do this, now do this, now do this, now do this, right? So that there is this complete lack of incentives for using your brain. I don't know. It's like this dumb problem of, well, you created an incentive where you said you won't pay me if I don't do exactly what you said, but I'm the expert. That feels weird. It feels weird, and a lot of engineers feel that weirdness of, I know I should be refactoring, I know I should be testing myself, I know I should be automating a large part of this QA, because QA doesn't know how to automate it. They're not engineers. I'm an engineer. I know how the system works. I'm the only person who is capable of expressing the abstraction on top of the components that I have built. But I need help to express it. I need help to figure out what the correct nuance of the word is, and how to display it, and how to separate noise from signal. I need help with that from product, from QA. Where am I going with this? Help me out. I was going somewhere with this.
I lost you, to be honest.
I lost you. I lost myself too. God damn it. Just give me 5 seconds. There was a point, but I waffled on for too long, and I lost the point. How late to watch the recording?
Yeah, we rushed the recording and then make a post out of that.
That awkward moment when it was brilliant. It was the best idea of this episode, and it just. God damn it. Let me retrace my steps, and it'll come to me. So it's this idea that you should not be that you should not be exploring all permutations of the system, because you want to define what the behavior is. I'm not talking about inheritance yet. That was the point. I'm not talking about classes. I'm not talking about interfaces. I'm not talking about this component extends that component. You showed the React example. This component contains that component as a child, and then what is the prop drilling strategy, and we know how that ends. The point of behavior is for me to be able to express the user's terminology. Domain-driven design, right? So I need to use the domain jargon of the problem, like automobile, not combustion engine crankshafting turning thing, right? So, and then the anecdote that I wanted to share with this is Adam Dimitruk, who's the inventor of event modeling. He has a very, very good process for software development, and he said, so he's one of the most, how would you say, controversial people on this. Because we get along well, we're good friends, but he's super anti-TDD. Because he said we've managed to get the product understanding of our process down to such a detail that TDD slows us down. Right? So he was able to sort of get complete technical buy-in from the engineers to solely focus on the data transformation pipeline, the modeling process, the state management of the system through event modeling and through the approaches he teaches through event modeling, that the event model itself is a high-level system test. It expresses behavior completely. Now, they still write tests, but they write tests that exactly capture the design of the model. And those are already a high level of behavior, which if you do TDD, just, it's a step in that direction and it might force you to go a different direction. So they actually ended up having more issues refactoring that way because their process, because their process of modeling, their process of planning, their process of communication, their process of collaboration, and most importantly, the product leadership and the product understanding in every brain automatically produced tests that expressed behavior. There wasn't this fear to be traversed of, oh, if I don't do TDD, I will make untestable code because I have no design, I have no plan. Given to my own devices, I will create a mess. And they have solved the business side of things to such a degree that the mess isn't there to begin with, so TDD would actually slow them down in most cases, which is super interesting, which is a very contrarian take, and it's probably like the only one company in the world that I know that works like this. And it's super interesting because they're like the exception to the rule. Because I would recommend you do TDD for the obvious reasons. And for him, I completely agree with him. Yeah, like he has solved the focus on behavior decomposition that TDD brings. He has solved that with event modeling instead. So what they're doing is they're doing non-coding TDD by modeling the behavior of the system. And it's not like Gherkin style BDD. It's not like some weird snapshot testing. It's not null testing. It's not mutation testing in like a weird composed way. And God forbid, it's not regression testing. It's not like that weird, let's do QA first and let's pretend it's a finished system. But they have actually managed to capture the behavior decomposition problem, which is really what we're talking about here, this episode. It's like who owns the definition of behavior, of who owns the definition of how is the system expected to behave. They have solved that, and they have shifted that all the way to the left, even before coding begins. Right? So they don't code before they have an event model. And the event model is a very, very good example of the behavior of the system. So by that time, they can just implement the system, write the tests for it, because the design, the brain step has already been finished. Whereas with TDD, usually the brain step happens very close to writing the test, and it's slightly further away from writing the implementation. But I've seen him work. It takes a lot of discipline to work like that. It takes a lot of industry understanding. It takes a lot of product understanding, and it takes a really well cohesive team to work like that. But I have been researching him a lot because he's a canary in the coal mine. Like he's the one person who I fully trust when he says no, TDD was bullshit for us. Right? He's the one person that I trust when he says, okay, so you found a viable alternative. And I find it really interesting, which is why I also a big fan of event modeling, even though I also like to do TDD. I find it to be very productive for my productivity, my team's productivity, my client's productivity. I just wanted to mention that, right? So that this isn't the only way of doing things, but the common denominator is not whether you're doing TDD or not. The common denominator is not whether you're doing QA or not. The common denominator is whether you are able to express the behavior, the correct behavior, the non-functional behavior, the incorrect behavior, the crash behavior of the system to the degree that the client cares about it, to the degree that your stakeholders are prepared to invest money into guaranteeing it. That's what this is really about. And when there's a dysfunctional siloing going on, you might say the engineers are guaranteeing that it's coded, and then the QA is guaranteeing that it's inspected, and then the product team is guaranteeing that it was defined, and then the architect guarantees that it was designed.
Okay.
Right? But then everybody's sort of passing, it's a hot potato. It's like, no, I implemented it incorrectly because I didn't guarantee the design according, right? So if you give me the wrong designs, I give you the wrong implementation. If you give me the wrong definition, I give you the wrong design. If you give me the wrong implementation, I give you the wrong test outcome. Like QA can test and say, oh yeah, actually the system works, but you didn't define it correctly, right? So it's working according to specs, but the user would never use it like this. You know, and you mentioned that insurance example. It's very easy to create scenarios that don't make sense. It's very easy to create scenarios where I say, yeah, this policy has been active since 2012, and in reality, it should not be active, until 2021, because there was a typo between 1 and 2. And going backwards in time, you can never, orchestrate a test environment where that data would reasonably be created and put into the system that way. But an insurance company, when it deploys that system, it will have that data in the system, and you can't go back because they have audit logs, right? So they have to sort of know, well, not only how does it behave, but when I put it into production, they actually have to have some guarantees on how the code fixes a bug. Even when you have like high-speed trading systems, like when there's like super stable and you have audit logs, you also need to know, like, well, we have replay capability. How do we do replay capability when we fix the bug? Should we replay the bug and then replay the bug fix at a certain date? Or should we pretend that bug never happened, because then the replay logs don't match, the hashes don't match? That's essentially rebasing. It's a complex problem. Then you end up into mathematical problems like conflict-free CRDTs, conflict-free replicated data types, right? So data types where you say, well, if you create sets that only increase, then there's a guarantee that you can merge resolve and conflict resolve, etc., etc. That's too complex for today.
And I think James does have a follow-up question or statement.
Yeah.
I can't find. I tried, but I can't find the actual comment on LinkedIn. Maybe you can.
He had a first comment. Let's look at that one first. He says, I like to set up feature flags for stakeholders, businesses to test, flip, and it is released. The more we can push to the business, even small HTML CSS changes, which IT should review and approve, the better. Less silos if we can't do that. If we should embed ourselves in the business, then program ourselves back into IT. I think quality suffers if developers are responsible for every single very small change. No double handling unless it makes sense and is large enough weight to be helpful. That's a lot of things to unpack there. But basically, it's this idea that if I build it, if you make a lot of requests, I shouldn't. If you give me a lot of detail and you sort of start micromanaging me, I will give you a feature flag and you test it yourself. Don't explain it to me, right? Because on my end, it's just a millions of permutations. On your end, it's just one thing that you care about. So I will give you the capability, you configure it, and you test it yourself. I like this approach. You see this a lot with B2B SaaS companies, where one tenant asks you to implement something for them, or to make an exception for them, or to turn something on. Like there's a tier, and then there's modules, and then they ask you, well, don't give me the entire tier. Just can you turn this module on for me, right? And you might just say, okay, well, we turned it on for you. You test it yourself. We don't guarantee that it works in this configuration. So we turned it on for you. You test it yourself. And if you find it valuable, we will actually go out of our way to make it viable for you, not just valuable. Now the second question. Sounds like their models and behaviors are tightly coupled. Okay, so what was this a response to?
This is what I because I showed it in the moment where it was necessary. I think
was this the UI, example?
The second last waffle, I think.
Okay, second last waffle. God damn it.
I can't remember exactly, to be honest.
Sounds like their models and behaviors are tightly coupled. Then you get into testing the internals of behaviors being pure-like functions passing in data models, or high-level behaviors need to be workflows. So this is the automobile crankshaft analogy. Event messaging boilerplate, me being controversial, breaks workflows. I agree with that. Yeah, I also hate event like any kind of message queue boilerplate. Like the moment I have to sort of inject message queue infrastructure into my whatever functions objects, I think there's something like if I can't use primitives to at least get that done, then we are probably vendor locked into AWS or Azure. But embedding assertions directly in code is a great way not to do TDD. Okay, let me reread that. Event messaging boilerplate breaks workflows, but embedding assertions directly in code is a great way not to do TDD. I see. So you define it almost like a observability assertion, so that if a scenario happens in production, it throws an error. So it says, hey, this bad thing that's not allowed to happen in production just happened. And then you have like an observability pipeline that monitors how often it happens. I think Facebook works like this, essentially. So it's a more canary, more observability focused way of slowly rolling out features and having it fail super fast, so that you can catch it in like a real, so that you can catch it in a real environment, rather than creating a simulation of something that resembles it. You know, maybe you can't simulate it because the production environment is too complex. You know, Facebook has 2.5 billion users. You know, it's so a lot of those billion users are in vastly different contexts. They might have hundreds of millions of different contexts, countries, cell phones, operating systems, etc. You are smashing your test into live code. Jim Coplin hates TDD. Jim Coplin is very controversial. There's a lot of things Jim Coplin hates. Jim Coplin hates TDD and promotes this way of coding. When he talked, oh, there's more. It's cut off. I got it open in my other tab. Thank you, James. This very, very good insights. Jim Coplin hates TDD and promotes this way of coding. When we last talked on LinkedIn in 2018. Yeah, I like this kind of, so this would be called precondition checks, right? So the code will often assert under what conditions it is allowed to run, and under what conditions, what post-condition checks might be there, right? So what you and I know as a unit test or a developer test that has an assertion, those are generally post-condition checks, right? So I run something, and then I check conditions. And there also exist precondition checks, which is usually why the kernel, the C level, I think it's a system call or a statement, assert, right? You can say assert x equals 5. That is usually a precondition check. Usually when designed by hardcore like kernel programmers or driver programmers, it is a precondition check. It basically said, well, this needs to be true. If it's not true, I'm going to send electricity down the wrong wire. So assert that it's true or fail otherwise. Like fail in the equivalent of a kernel panic, or fail in the equivalent of a very serious exception. Not catchable exception, but just very serious exception. Something's really not okay if this wire check didn't go through. And I think those would be precondition and postcondition checks to the ones that I think Jim Coplin mentions and now James paraphrased. But I find that very difficult to do. Again, on the Lego analogy, I find it very, very easy to do on one atomic Lego piece. I find it very difficult to do on links, right? So architectural links between compositions of multiple pieces that capture an abstraction. And I see this a lot. You know, when I'm testing by the book, I might say, oh, here's this behavior. And the behavior is I create a class. The class has 4 controlled dependencies. The dependencies are in a certain state. And then I call a certain function. And then the thing that I get returned is another object. And then I assert something on that object. That's one unit. It involves 7 functions, 10 classes, 2 interfaces, a mock of some kind, and the return value is of a certain signature. Most people wouldn't know how to, write assertions into each atomic piece to make that linkage correct itself. Most languages don't even support that. I have huge respect for languages like Zig, like Rust, TypeScript nowadays, F sharp, F star got mentioned in our comment threads this week, of just having more mathematical functional programming ways of actually verifying whether, can this execute? If it can execute, what are the allowed conditions to execute? I think that's then taking a very much technical approach to exploring those permutations of possible test cases without actually writing all of them down, by just having a very good typing system and a mathematical typing system that you can sort of prove to be correct. But that's more in the functional programming, Elixir, Haskell, etc., Erlang. Yeah. What else? I think that covers everything. We had one more topic to discuss, which is that idea of flaky tests and slow tests. Who's responsible? My opinion is that, it's an engineering problem. It's a speed problem. Who needs the feedback? Does the
That's
QA
a good
team
point.
need it? Right? Who needs the feedback? Does the QA engineer really care about feedback? Or is the QA engineer passing it on to someone? Right? So it's always the person's problem who needs the feedback. Who needs to know whether a feature is being used or not? Is it engineering? Is it product? Is it the stakeholders? Is it the CEO? Is it a combination of all of these? Right? So it's always the problem and the responsibility of the person who needs the feedback. Tests are slow. Well, who needs the feedback? Some behavior is failing. Well, who can do something about it? Who can fix it? Who can fix the failing behavior, not the slow test?
Yeah.
Well, if the fix of the failing behavior has to go to the business analyst, well, guess what? It's the problem of the business analyst. The business analyst should be pushing for faster feedback cycles, for continuous delivery, for chunk-based development, for more simulation. Sometimes the problem isn't the test runners. Sometimes the problem is just nobody wrote a simulation. People said, oh no, like we have a scheduling software where I can schedule a recurring event that repeats once a month, and our test is to put something on the calendar and then assert the next month whether it was successful. No, dummy. What you need is a simulation where you can mock the date and then you can simulate 1 month having passed. That's an engineering problem. That's not a behavior problem. Somebody needs to think about that abstraction so that it can be captured, spied, mocked, doubled, stubbed, faked. Ideally in a way that stubbing can be done at the topmost public interface. So it doesn't require like deep, decomposition, reflection, like passing it down, like the equivalent of prop drilling with tests. So that behavior can be tested without waiting for a month. The hardest problem that I had to test at some point was a automated tournament manager for Dota 2. Dota 2 is a 5-on-5 game, and the tournament, in order for the full simulation of the tournament to be reasonable, required 4 teams, because we needed to have quarterfinals, semifinals, right? So we needed at least 4 teams. So that's 20 people. So that's 20 API calls in parallel, 20 open socket connections, and then admin socket connections, and then game clients and game keys. So I had to, at the very least, for one integration tests, we always had one piece of the problem where we solved it with QA processes. What we thought was good QA process. We would say, okay, now it's done. Now let's do that annoying thing. We would get 20 laptops into the office. There were 7 of us. We would get 20 laptops into the office. Everybody would sign up. Everybody would have an assigned username and password. Everybody would join the lobby. And everybody would register their team to the tournament. We would start the tournament, and the invites would go out, and people would run around on laptops, accepting the invite, joining the game. Because we thought that's what QA is, doing everything possible to ensure that the pipeline was tested. And that's not the case. What we required, I then later learned, was QA-like coaching for somebody to come in and say, guys, it takes 7 of the most highly paid people in this company to spend 3 hours disrupting the entire ecosystem to bring 20 freaking laptops into the office to run one test scenario once. That's a problem. We need to simulate this so that one person can run it on their machine locally. And then after that, the CI pipeline being able to run it locally without a human being involved. Right? So what we were lacking at the time is somebody with enough experience to tell us, guys, this is a problem. The fact that a human needs to be involved, let alone 7 humans, and that we need 20 laptops, and that it's manual, that's a problem. And a lot of people have pipelines like this. A lot of people have pipelines where they say, okay, tests are passing, it's on staging. Steve, go do your QA thing on staging.
Mm-hmm.
That's a problem. That's a problem.
But is this still a big case out there? So maybe in the audience, we haven't asked something. Audience, please tell us if your environment is more looking like what Dennis just said, or is it actually already that there is a good collaboration between engineers and business in regards of testing? That would be really interesting. Maybe we even make a LinkedIn poll for that at some point.
Yeah,
I got good results for the TypeScript one.
Yeah,
it could be interesting though.
Because the context is important here. What I found the most is that generally we were very much product heavy back then when we were doing this.
Mm-hmm.
And we solved it by just automating it, by just really taking QA seriously, by shifting left QA. We got a QA person and we said, we're not doing QA in order to do QA manually. We're doing QA to make QA testing manually obsolete. Like we will simulate everything, automate everything. We will get everything into the freaking pipeline so that I can trust my pipeline. So that then when you're testing manually, at the very least, you will know that the robot said it's mostly okay. You can now really look for, inspect for like really nasty, unexpected things that maybe you should check.
Mm-hmm.
The part that I wanted to highlight here is that we had very high product understanding. So we quickly identified that this was an issue. I see a lot of engineers disincentivized or desensitized. They had that gut feeling of this is a problem, but they got used to it. Right? So when there's engineering teams where they say, oh, we just don't test anymore. We have that one test, that big, like doing inventory at like a supermarket. Like we just have that one test that we run once a month, and that's our sort of guarantee that that's good enough for now. And we never want to go faster than that. It's like it's the same story that I hear with people who are resistant to, with leaders who are resistant to continuous delivery. They say, oh no, we release once a week. That's good enough for us. Or release once every 2 weeks. That's good enough for us. Right? So there's the resistance to say, actually, no, like there's a feedback mechanism to how fast you release in relative terms to how long your shift is. A shift as in typical worker mentality, the worker meaning of the word shift as in an 8-hour shift or work shift or 2 4-hour work shifts in a single day. The longer the feedback cycle is relative to that, the more you're at risk of getting feedback too late on whatever it is you're doing.
Or you get none. So oftentimes you don't get the feedback. I think that's one of the biggest problems out there.
And that is what I want to highlight. How many times have you seen where people said, oh, feedback takes too long, so I'll just continue without the feedback? Right, so the correct behavior, I think, if you want to really grow as an engineer, is to say, no. The feedback takes too long. This is a problem. I'm going to address the problem. We need feedback faster. Like, to me, that's what Agile is really about. Just stop work and say, no, if I built this, I want freaking feedback. I'm not going to start building something else just because we gave up on waiting for the feedback. Because it's the equivalent of, and I hope Callahan hears this because I finally got a good restaurant analogy. It's this idea of you go to a restaurant, you order food, it doesn't arrive in 7 minutes, and then you go to the next restaurant. You just leave. Then you go to the next restaurant, and then you order food, it doesn't arrive in 7 minutes, and you go to the next restaurant. And then the only restaurants where you'll ever be happy is McDonald's, because they give you your food in 4.7 minutes. Right? So
No,
because they guarantee that to a certain degree.
there is no guarantee.
Right? But
2 weeks ago we ordered, just an anecdote. I stand there. The air conditioner was broken. It was a hot day.
Oh no.
So many people were standing there, and I ordered at this new terminals, right? Standing there for half an hour in that heat in front of the kitchen there, or in this, on the counter. And finally I got out, and while we were driving, we just realized that they forgot all the burgers.
Oh no.
That was not so cool.
That is not cool.
No, I just
you run
wanted to
the test?
complain here on stream about that.
No, but my point is that if you keep switching restaurants because there's no feedback, you didn't address the issue of, is feedback coming? I'm just impatient? Or is feedback coming so late that I need to communicate in advance, hey, I'm in a hurry, what should I order so I can catch my meeting in 15 minutes? Because that's how you order responsibly, when you know that you're not going to wait for the feedback, or if the feedback takes a very long time to arrive. And usually that equivalent of, hey, I'm in a hurry, what should I order so I can X? That's what right sizing generally is. That's what really continuous delivery comes down to. Is this idea of, okay, deadline is tight, we're in a hurry, what should I work on so that we get feedback on X? Right? I'm in a hurry, what should I work on so I know immediately, what the next step is? And everybody in the team needs to adopt that stance. And now translating that to our topics today on user acceptance testing and QA testing, the user acceptance testing would be very simple. What should I test? What should I define to be tested? What should I encourage to be tested? So if it fails, the developers get instant feedback that we're going the wrong direction. That's a good test. Plus, ideally, the test should tell them what failed, why, and if it's in our economic interest to fix this test, what needs to be fixed. Because sometimes people just write bullshit tests that say, oh no, that's okay. That one's flaky and we don't care about it. Or it's a behavior that we defined, it's gonna be on version 2, we turn it off. That's okay, but please remove those tests. If you wrote tests for all business requirements that you wrote in your spec, you also wouldn't pass. Because as you're developing, you're making decisions. You're course correcting. Right? The point isn't that Agile says don't plan. The point is that we don't rigidly follow the plan we created 1 month ago. That's what Agile is about. There still is a plan. It's irresponsible not the plan. The differentiating factor is that we don't blindly follow a document that somebody with limited knowledge has created a month ago. Whether that's a roadmap or some kind of optimistic best effort prediction of how the project could go, that is irresponsible. And testing like that is also irresponsible. Right? So I agree with people who are and don't agree. I understand the people who are saying, I can't do TDD because how can I write the test if I don't know how it works? I understand that. But my feedback to that is that the point isn't that you understand what it does. The point is that you understand which of the failures are important so that you'll take it seriously enough to course correct. See, if you're not course correcting, if you are not course correcting, if I order burger, cheeseburger, Big Mac, and after the second burger is burned, you don't course correct, I have no chance of winning here. right? Because you'll just blindly follow the plan. But now there's an issue, right? So one of the customers we broke the guarantee with. We forgot their 3 burgers. If you're just
Now I'm
blindly
hungry,
following,
actually. That was a
if you're just blindly
was a
following the
failure.
plan, if you're blindly following the plan, you have no business doing TDD, because you are never asking questions about, oh, am I going the right direction? If I'm not going the right direction, well, I need to change course immediately because the test will be telling me.
Mhm.
You know, TDD practitioners have this like weird dopamine kick of they'll create an abstraction. Have it in my mind. It's super easy. They write it down, and after 10 lines of code, they're like, God damn it. I said it's easy. I had it in my mind, and I wrote it down, and it just became immediately this entangled mess. And what they do is they immediately take, okay, too large step. They say, too large step. And they delete what they wrote, and they simplify, and they make a smaller step. Because they were prepared to admit, you know what, I was wrong. Let's go back one step, and let's try again. That is, like, that level of just putting your ego aside, not being resistant to what the compiler tells you, that is very valuable. The amount of times that I've seen people say, I can't do 3D because I don't know how to test it, and they have 7 tickets to finish this week, and they just start coding, and it doesn't work, and then they start coding it from the other side, and they always follow this dopamine trail of which area of the code will give me the least resistance. And then they start integrating, and then they put it all together, and they hit F5 in their browser, and it breaks. And then there's one error, and another error, and another error, and then they just do this sort of this reduction of, I'll just keep refreshing and fixing all the errors as they pop up. But that kind of workflow does not guarantee getting to an error-free state. And then they got stuck, they go to lunch, they come back, it still doesn't work. They can't commit it because it doesn't integrate. Then they go on a branch. They put that branch. They call the branch work in progress, and they give it the ticket number. And then they go out and are stuck on 4 hours of meetings. Tomorrow morning, they come back to work. They're super upset with what they wrote the day before, and then they have to regain context of what they were working on. And then somebody tells them, "Oh, plan change. We need to do X instead of Y. Refactor that part of your code, please." And if it wasn't working in the first place, then now you're essentially stuck.
Comment, wrap up.
James says, on his most recent comment, test first is a great way to discover how you want something to work like a message box. Yeah, so input, output, right? So state-based testing, right? So when there's no social testing, there's no component that you have to control. Avoid functions are social tests, right? So I have a void function. It doesn't return anything, but if it's a class, it might have a dependency, and I put something in, and then I inspect the dependency for a side effect. Right? That's a social test. Write it in a test, have it pop up, then learn how to mock the external resource once. You get a quick idea how the pop-up works. Then you can write or refactor it to a behavior test. Yeah, that's exactly right. And then you can go one level deeper to get the behavior of the side effect. And then you create a new test just to cover that side effect. Because then you actually, pull it apart, create components, put it back together, have it, wrapped up in an abstraction, but internally you just have the void function you pull apart, and you make it internally a pure function inside. You capture the side effect. Even if the side effect says, I have called PayPal and PayPal returned X. I have called PayPal and PayPal rejected with error message, this and that. Right? So even when the end result ends up being a type that you can replace with a virtual service, Brian Finster is a huge fan of this kind of contract testing with virtual services. Then you can mock external resources and convert the state test to a behavior test. We do have an episode coming up on this topic next month. Adrian and I recently made a little bit of a content plan, so there's a little bit of testing, refactoring.
I try to be more awake next time. I'm very tired today.
No, it's okay. It's okay. It's okay.
I haven't slept much the last two nights. Okay, wrapping up maybe a little bit.
James wants waffles.
James, for today, you get honored with a waffle as well. Thanks for waffling with us.
Yeah, thanks for waffling with us. So let me know what you think. So this was our coverage on sort of cultural discrepancies, cultural issues when it comes to overlaps in responsibility on TDD, user acceptance testing, integration of behavior testing and expectations from the system, behavioral expectations from the system, and a QA department, a QA process. To wrap up on what you can do, the shift left strategy is the most popular one, I would say, where you ask the question, who cares about the feedback? And then you get the feedback as close as possible to the person who cares about it. If there's no organic way to do it, you need to create that feedback by simulating something, right? So that's the anecdote when I said, oh, we had 20 laptops in the office. That's cool, but us doing that manually is still too long. So I need the same amount of data. I need to traverse the same code paths with a simulated environment because I need to make it faster. What James mentioned, you can also do that for mocks to really get confidence in getting a state-based or side effect-based unit of behavior controlled. Then you can extract the behavior, convert it, mock it, and then you can control it in a way that you can maybe replace it with a virtual service, or at least, like a mock framework, although I'm not a fan, like a mock framework virtual service that was auto-generated for you. Some languages allow that, some don't. Like in Go, I wouldn't recommend it. In TypeScript, go nuts, because it's more dynamic. And then ultimately, the responsibility for QA, at least in my opinion, again, depends on context, but ultimately the responsibility is to coach QA practices, is to coach and say, no, the way we're testing is a problem. This is the extreme of how fast we could go. This is the extreme of what it looks like to be completely rolled over by technical debt. And we are here somewhere. And rather than having a KPI for what the lead time is on merging, what you really want the QA department to do is to measure changes, trends over time. Hey, as the code base is growing, are we speeding up or slowing down? That's a much more important metric than just looking at red or green, than just looking at the number of tests. But what you really want to do is when the code base is growing, you want the speed of the test suite to speed up. Because otherwise you will never catch up. That's what a QA department could do when they're benevolently empowered, and then coach all the engineers that care about it. Because ultimately QA doesn't care about failing tests. QA will just say, doesn't work, and toss it over to engineering. It's the engineering department that should really care about it. Or product engineering or product leadership, or if the CEO is more of a VP of product and engineering, then they should know about it, and it's usually just optimizing their ability to focus, to communicate clearly, and to set a vision.
Good, yeah.
Last words from you, Adrian?
Last words for today.
Off the bed?
Off the bed, then. Actually, I need to ride home with my bike. It's actually an interesting topic. So, a little bit of high level right now. TDD, so every time you have TDD on LinkedIn, for example, right? You
Super
get into...
low level. Yeah. It
is very super low level. And people are constantly going into what is a unit? We don't need it. There are so many. Yeah. You can make a list and it will repeat itself. So it's a little bit, on some point, boring because no one is really talking about why we're doing those things. Yeah. And I see that often, especially with engineers. So engineers are very much like, they sometimes overly care about specific aspects of their work, the craft. And on the other side, business people are oftentimes not caring about tech at all. And this is why I'm talking so much about the gaps and that's the distance between those both instances. And in my opinion, we should all think a little bit more about why, right? So why are we going or why is TDD actually a good idea? Or maybe inverse that. Where do we have problems? So, and I'm 100% sure that people come and will tell, yeah, of course, I know we have problems with that. Let's say the quality is flaky. Sometimes it's working. Sometimes people tell us this and that. Have you tested? No, we don't have time. And it is sometimes taking a look from that direction, right? So first of all, TDD, of course, it's not primarily about testing, but the good aspect is you have tests done.
Yeah.
You have more confidence. You build the entire architecture. So if you ask people about, do you have, let's stick to front end because this is my expertise now. You have a front end solution there, and everyone is actually saying, I don't know if the architecture is good. We have so large components. Everything is actually very monolithic. We have a lot of let's say coupling where we don't want to have it. And then you ask, okay, what is your measurement? What is your solution to solve that problem? Actually, we don't have time and this and that. And no one is really thinking about that. TDD is actually solving those problems, because if you can test it for yourself, if you write a component and just write a test first, it must not be a complicated test. Just write down a test, a very first expectation. Sometimes that's already enough. It's better than don't do any tests. And then you write it down and you say what you actually want to have, and then you think about what would help me to become less mad about our own code base and workflow and stuff like that. Just write it down and then you work towards it. And suddenly you see, okay. And I had that today. I gave a coaching again about TDD.
You keep saying you don't do TDD workshops, and now it's your second TDD workshop in 2 weeks.
Yeah, there's even ordered more. Okay, but the other one was we were basically going through the idea of what is the data flow in React. Data down, mutations up, and stuff like that. And what is TDD coming into play when it comes to do with ports and adapters or hexagonal architecture. And when you do TDD, the outcome is most often something in a ports and adapter pattern. So you start to develop a component in the manner of creating a port, right? So you understand,
you want to control it, because the test might be having a side effect, you want it to be social, so you want something that you can later mock.
Exactly. So you start with a mock implementation, which is your adapter in that case. And you want to, in our case, it was basically a state-based component. So basically the paradigm of React, so I have the state, and if you mock the state, you will see something. And this is the idea. So this is basically the port, and the adapter just mocks the state. And in reality, the adapter changes. You have a different adapter, and you have then basically the real implementation, the real state.
The signature of the adapter stays the same, right? The type of the adapter is the same. The interface of the adapter stays the same. That's really important. Right? So the adapter that when you mock it doesn't have a different signature. That's a constant.
Exactly. And the point here is that when you use TDD, so for a moment, get rid of the T in this one. Just if you practice that practice, right? Then you design those things better. Even if the tests will be deleted later on, it's still better code because you have created a better foundation. And I think this is what most people ignore when it comes to TDD. And this is what I observe anyway on LinkedIn especially, is most people tend to criticize things but never have really used them. And then with use, I don't mean, hey, I've checked out a test project and tested it for 10 minutes. I really mean used it in production over a longer period of time and see, or let's say, have a proof for the hypothesis in that case. And this is what I see. So, in fact, and I understand when you are in a hurry, you have pressure. Yeah, there is someone pushing you, or you have already a backlog of 3 things to do, and it's already afternoon, and you think to yourself, I need to get this stuff done. And of course it's like, do I really need to test now? I can do that myself this way. Come on, I'll do it.
But it's too late. But it's too late already, right? It's too late to write the test at that point.
It is that the problem is the process is not good in that moment. So this is the next step. So we as engineers should be aware
You're writing the test tired. Like, that's not a good outcome.
Exactly. Exactly. And this is where people fail with TDD. They say it's an overhead. I lose time. It's not even worth it. The test is flaky. It doesn't really work. I need to refactor very often. And sometimes sometimes it's better to not write a test, I would say, and fix the process instead. But
Yeah.
keep it in mind and write the components in a way that you would have the same outcome, and then later on extend it. So even I have done that with Cloudbar quite a lot, to be honest. So having that idea of sometimes it's simply impossible because you have constraints. You cannot just ignore constraints. They are there and they constrain you. So you can't do, but you can keep that in mind. But when you never learn TDD, and this is the aspect, when you never learn it, when you never learn what good ports and adapter pattern is, hexagonal architecture, then you can't do that without tests. Then you keep building those monolithic spaghetti code components, or in the backend it's the very same, way too large classes, way too much coupling.
Yeah.
Exactly. If you have learned it once, so let's say you are a practitioner and you don't write a test, your code will be better because you have created habits and a project. Exactly.
But you've skipped the test writing. But it's still designed
Exactly.
in the correct way.
And this is what I wanted to add today because I think this is important. And
If you're done with your monologue, I would just like to read a quote from Kent Beck.
I actually need to go. I have an appointment. I forgot. I just got a message.
Okay.
But the appointment set is probably too late, so I have maybe when I'm leaving now, no problems at all.
So I just wanted to read from Kent Beck from his 1999 book, Extreme Programming Explained. TDD is a discipline that stemmed from extreme programming. And I just want to read to you. This is the last chapter in the book. The last chapter. I just wanted to read to you from 25 years ago why it exists. From Kent Beck's words directly. Okay, and I quote. Kent Beck says, all methodologies are based on fear. You try to set up habits that prevent your fears from becoming reality. XP is no different in this respect from any other methodology. The difference is in what fears are embedded in XP. To the degree that extreme programming is my baby, extreme programming reflects my fears. I am afraid of doing work that doesn't matter. I am afraid of having projects canceled because I didn't make enough technical progress. I am afraid of making business decisions badly. I am afraid of having business people make technical decisions badly for me. I am afraid of coming to the end of a career of building systems and realizing that I should have spent more time with my kids. I am afraid of doing work I'm not proud of. Extreme programming also reflects the things that I'm not afraid of. I'm not afraid of coding. I am not afraid of changing my mind. I am not afraid of proceeding without knowing everything about the future. I am not afraid of relying on other people. I am not afraid of changing the analysis and design of a running system. And I am not afraid of writing tests. I had to learn not to fear these things. It didn't come naturally. Especially with so many voices crying that they were exactly the things I should be afraid of. The things I should work very hard to avoid.
You should create a video out of that and read that and then explain why. Or record it right now and then show it to the world. Because this is actually quite important. It resonates, and it should resonate with everyone who were part of a serious business, serious product development, development cycle. It doesn't matter, because if you haven't been in such a situation where you are, let's say, bound to any form of pressure to a company, where the company actually haunts you even in the night, and you have the feeling that you don't have time with your family anymore, you are probably not a senior yet. there's a big chance you aren't, because a senior, just because of pay grade, I see there 25 years old people are senior roles. That's companies can do that, but they are not seniors for me. Sorry to just say that, because when you get into seniority, taking ownership, responsibility, you try to avoid exactly those things, and you can you can smell a real senior from 100 meters away if you're one yourself. You know exactly how the people react to problems, how they see things, how they react to opinions. And it's not like this hurrah, we are going to, and yeah, it's no problem at all. No, seniors are mostly pessimistic people, and this is what comes after the Dunning-Kruger, right? It's what when you become a little bit more humble, because you know how hard that actually is, and how this can actually, let's say, doing it wrong can ruin your life, at least for a while. And this, even if you, on some points, in some special things, edge cases, even your life. And you should be, should take care about that, because the more responsibility or accountability you have, the more ownership you need to take in order to not mess it up. And ignoring something like TDD entirely and saying this doesn't work is simply ignorance. That's simply ignorance. There's nothing more than that. If you say we have tested it, it's not part of our environment, we ensure it differently, this is a different story. But telling that it is not working and a bad idea, there's no respect for that. So that's some just saying that this is either big resistance there, which is overwhelmingly strong in yourself, and you will find anything to throw against the TDD movement, or you are just a person who doesn't know what he's talking about. And,
or you're burnt out. And
exactly.
You don't have the energy, and you just gave up on it. And
but just because
you don't know, because you didn't have the energy to try.
Every time something fails, and I have problems because of it fails, business problems, money problems, just stress, something like that, and I know TDD, or let's say feedback from continuous delivery, those kind of things could have helped us in that moment, because I don't know why, but there was reasons we haven't done it. And I think to myself, how stupid that actually is.
Yeah.
And it is a little bit, it is always more expensive in terms of mental stress and stuff like this.
And you carry it with you. It doesn't stop.
But I need to go now. Sorry, I really need to go now.
Okay.
You can wrap up, everyone. Goodbye. I need to go. Bye-bye.
Ciao. See you next time. I just wanted to end on the thought that the story that Adrian mentioned, even though you should have done something and you didn't, that feeling still keeps haunting you of, we should have done it a long time ago. But even today, we don't do it. Even though you're wishing, we should have done it a long time ago. Well, the natural consequence is, okay, let's do it today. Let's do it today. Let's face the fear today. And then what I see a lot of teams sort of degrade into is this attitude of, we should have done it a long time ago. And the consequence of that thought is to propagate it into the future. Okay, maybe tomorrow. Right? Not, we should have. We're doing it today because we should have done it a long time ago. It's that courage that says, if we should have done it a long time ago, then we're doing it today. It's the responsibility to act responsibly. Thank you for sticking with us today. Short elevator music, and we'll see you next week. We're only streaming once a week now. We have a much more planned out content plan to sort of increase the quality and the regularity and the consistency of the shows and the episodes. We have a few new guests coming on. We have Maria coming on next week to talk about how to fix a legacy code base. And we're in talks with Sander Hugendorn on technical leadership for July. The rest will fill in with content topics that truck-based development, pull requests, engineering culture, CTO topics, and TDD and continuous delivery. Thank you for being with us today. Ciao.